Hi everyone. Today our topic is about dynamic method binding. Virtual functions in C++ are an example of dynamic method binding. You don't know at compile time what type the object referred to by a variable will be at runtime. Simula also had virtual functions, all of which are abstract. In Smalltalk, EFL, Modular 3 and Java, all member functions are virtual. Note that inheritance does not obviate the need for generics. You might think, hey, I can define an abstract class, then derive int list, person list, etc. from it. But the problem is you won't be able to talk about the elements because you won't know their types. That is what generics are for, abstracting over types. Java does not have generics, but it does have checked dynamic cast. Data members of classes are implemented just like structures, like records. With single inheritance, derived classes have extra fields at the end. A pointer to the parent and a pointer to the child contain the same address. The child just knows that the struct goes further than the parent does. Non-virtual functions require no space at runtime. The compiler just calls the appropriate version based on type of variable. Member functions are passed an extra hidden initial parameter colon. It is this called current in EFL and self in Smalltalk or Python. C++ philosophy is to avoid runtime overhead whenever possible. This is sort of the legacy from C. Languages like Smalltalk have much more runtime support. Virtual functions are the only thing that requires any trickiness. They are implemented by creating a dispatch table vtable for the class and putting a pointer to that table in the data of the object. Objects of a derived class have a different dispatch table. In the dispatch table, functions defined in the parent come first, though some of the pointers point to overridden versions. You could put the whole dispatch table in the object itself. That would save a little time but potentially waste a lot of space. This is class foo, int double b char c, then public virtual void k, virtual intel, virtual voidum, virtual double and f. So vf contains the variable abc and foos vtable contains klmn. Implementation of virtual methods. The representation of object f begins with the address of the vtable for class foo. All objects of this class will point to the same table. The vtable itself consists of an array of address, one for the code of each virtual method of the class. The remainder of f consists of the representation of as fields. So we can see implementation of single inheritance. As in previous figure, the representation of object B begins with the address of its class vtable. The first four entries in the vtable represent the same member as they do for foo, except that one m has been overridden and now contains the address of the code for a different subroutine. Additional fields of bar allows the one inherited from foo in the representative of B. Additional virtual methods follow the ones inherited from foo in the V table of class. Next is multiple inheritance. In C++, you can say class professor, public teacher, public researcher. Here you get all the members of teacher and all the members of researcher. If there is anything that is in both same name and argument times, then calls to the member are ambiguous. The compiler disallows them. Next is virtual base classes. In the usual case, if you inherit from two classes that are both derived from some other class B, your implementation includes two copies of B's data members. That is often 5. But other times you want a single copy of B. For that, you make B a virtual base class. Probably have seen this. Consider the base object class in Java. Next is object-oriented programming. Anthropomorphism is central to the object-oriented paradigm. You think in terms of real-world objects that interact to get things done. Many object-oriented languages are strictly sequential, but the model adapts well to the parallelism as well. Strict interpretation of the term uniform data abstraction, everything is an object inheritance. Dynamic method binding. Smalltalk is the canonical object-oriented language. It has all three of the characteristics listed above. It is based on the thesis work of Alan Kay at UTA in late 1960s. It went through 5 generations at Xerox PARC where Kay worked after graduating. Smalltalk 80 is the current standard. Other languages are described in what follows. Modular 3 contains simple inheritance, all methods virtual, no constructors or destructors. ADA 95 tagged types is there, simple inheritance is there, no constructors or destructors, class-wide parameters, methods static by default, can define a parameter or pointer that grabs the object-specific version of all methods. Base class doesn't have to decide what will be virtual. Notion of a child packages as an alternative to friends. Java interfaces mixed inheritance is alternative to multiple inheritance. Basically, you inherit from one real parent and one or more interfaces, each of which contain only virtual functions and no data. This avoids the continuity issues in multiple inheritance above, allowing a very simple implementation. All methods virtual. Recap of all languages. Smalltalk is really pretty purely object-oriented. C++ can be used in an object-oriented style, but is arguable that it is a pure object-based design. Why? Note that symbol types are not classes, has subroutines outside of classes. C-style functionality provides more major loopholes that pure object-oriented languages wouldn't allow. Typecasting, garbage collection, etc. So this is all about this video. I will come with the next